All right, and the last thing we're going to review in terms of trigonometry for right now is solving equations. So how do we solve an equation that involves sine and cosine? All right, the first thing to note is how many solutions are there going to be. If you remember, the graphs of sine and cosine are these waves. So we want this wave sine. Let's just call this one sine. There's no label, so it could be either one. Sine, and we want to see when sine is equal to some y value. All right, this y value is this horizontal line. And you're going to get this infinite number of answers because this wave is going to keep hitting this line. All right, so we're going to get an infinite number of answers a lot of times. All right, so there's kind of two different ways you'll be asked to write your answers. Sometimes they'll ask you to write your answers in the first circle, which just means all the answers between 0 and 2 pi. Right, kind of that first circle before you start doing repetitions. The other one is to write all the solutions, and there'll be a little shorthand to do that, because obviously you can't list off an infinite number of solutions. All right, so how are we going to do that? All right, say we want to figure out when sine of x is equal to the square root of 2 over 2. All right, well, if we think about what sine is y values on the unit circle. It's just saying our y value is equal to the square root of 2 over 2. Well, y being square root of 2 over 2, that's a positive number. It's somewhere up there. All right, here's the origin. So there's two different angles, all right, that are going to give me an answer. All right, this angle there and that angle there. All right, well, one of these angles, I know because it's in the first quadrant, all right, this top right, that's going to be in the chart. When is sine the square root of 2 over 2? That happens when x is pi over 4. All right, the other angle I can't get from the chart because it's not in the first quadrant. What I do know is if I reflect this pi over 4 angle, it's going to turn into this reference angle over here. All right, so the angle I care about, this yellow angle, let's call it, I don't know, B. The angle B is going to be the half circle pi minus that little reference angle I already found, pi over 4, and that's 3 pi over 4. All right, so that's my other answer, 3 pi over 4. So it's just kind of going backwards using reference angles like we did when we were finding values of sine and cosine. And most of the time, or some of the times when you just want to get your angle or your answers between 0 and 2 pi, that would be your final answer. So this sometimes will be your final answer. Right. Other times, if you want to list off every solution, the way you do that is you just put these two things at the end. All right, so plus 2 pi k, we said every single time we do 2 pi, we end up back in the same place. We'll get sine being the square root of 2 over 2 again, and k just means some whole number. So I'll do 1 full revolution is 2 pi. 2 pi twice would be 2 full revolutions, 2 pi 3 times, 3 revolutions. No matter what, I end back up in the same place, and I'll still get the square root of 2 over 2. All right, so if you want to kind of write a shorthand for your answer, for every single answer, there's infinite repeating answer, you put this plus 2 pi k at the back. If they just care about the first set of answers, you just do what's in white in the red box. All right, so there's ones. You kind of just use the angles. All right, one thing with all these trig functions, the first thing I want to do is solve for the trig function, get it by itself. So here I'll just add 1 and divide by 2. And there's one wrinkle in this one that wasn't in the last one. This is this 4x. All right, so I'm going to make the problem easier at first by replacing this 4x with just a single letter. So I'm going to change this equation into cosine of u is 1/2. And because if I'm just looking at a single cosine, I can use all the stuff we know about the unit circle. Cosine's x value is, I want my x value to be 1/2. So there's two different angles that can do that. This angle here and that angle there. All right, using my table of values, cosine is 1/2 at pi over 3. All right, so this angle here is going to be pi over 3. The other angle I care about, which again, let's call it B. B is just missing this little reference angle there from being a full circle. So B is going to be the full circle 2 pi minus the reference angle, pi over 3. That's going to be 5 pi over 3. All right, so to solve the green equation, it could be this answer, or it could be, again, if we want all the solutions, which I'll just do all the solutions for now. All right, so this would be the answer to this green equation if that was our original problem. But from our original problem, we made this change to make the problem simpler. We remember that u is actually 4x. So now I get my final answer. I just divide everything by 4. And that's the final answer to the problem that I started with. All right, so when there's extra stuff going on in the parentheses, most of the time what you'll do is just replace it with a single letter. That way we can solve it like we did the previous problem. And then at the very end, just kind of undo that substitution by doing some division or multiplication. So although it looks a lot more complicated, you're basically just adding one extra step of doing this substitution here, solving it just like we did the previous one, and just kind of undoing that at the end. And we'll do one more type of these problems, and here's where you have multiple trig functions going on. There's a lot of different identities, so you might have to do some simplifying like we did in the last video of kind of canceling things out. Here, everything is just sine and cosine, so we can't do that. But one thing that's going to help a lot in pretty much all situations where you don't know where to go is to get 0 on one side. Because when we have 0 on one side, there's a lot of different tools we have. The main thing being factoring. I can factor out this sine of x. And these are 2 cosine of x minus 1. And because I have it equal to 0, if I break it down into factors, the nice thing with it being equal to 0 is this gives you just 2 different equations. Right, the factors are equal to 0. Right, sine of x equals 0. That's when your y value is 0, which happens right at the start, which is the 0 angle, and at the half circle, which is the pi angle. Cosine, or 2 cosine of x minus 1, just like in the last time, I'm going to add 1 and divide by 2. And this is actually the exact problem we had in the last time. Cosine of x equals 1/2. We figured out in the first quadrant that happens at the pi over 3 angle. In the fourth quadrant that happened at 5 pi over 3. Right. So again, if you just care about the, oops, I'm not sure what I did. Here we go. If we just care about the angle between 0 and 2 pi, all right, this would be our final answer, these 4 angles together. If we care about the shorthand for writing every single angle, we would just put plus 2 pi k. I just add this one extra thing to the end of our answer to get every single solution with the repetition that's going to happen. All right, so you can see there's a lot of different ways to solve trig functions. All right, knowing how to solve the basic sine or cosine equals a number is the start. All right, use your kind of unit circle in that table to kind of inform you about your answers. And then once you start having more complex equations, a lot of times just moving things around to where you can break it down into smaller pieces and then solve them like that. All right, so it's a quick overview of how to solve equations that involve sine and cosine. All right, so now we're going to do some more practice with those trig functions, simplifying, SOHCAHTOA, and solving equations involving sine and cosine.